Hello, everyone. How's it going? Hope you enjoyed the last session with Wei about Figma, learning to design with Figma, learning to code with Figma. And now I'm back for at least for now, the final part. Like I prepared for 5 sessions. This is the last session. And yeah, hopefully we are all excited for this one because, again, it's the end of everything. uh, and the beginning of you going and learning on your own. Okay, I think this is perfect. So, some background music as always. And before we proceed further, can I kindly request you all to please register for the session? So, if you haven't done it already, please do register for the session. Helps me, helps MLH. Okay, you get points. I get to know that you were attending. MLH knows that you were attending. Oh, a bunch of other things around that. Okay, so with that, I am going to answer one question that was asked at the end of previous session. But before that, actually, let me give you a very quick intro, 1 minute intro, starting now. So what we have been doing, we have been learning Python with finance with Python actually, and we learned the basics of Python. We learned about uh, like from the very basics, data types, all those things. Then we worked with pandas and NumPy on some financial data, some real financial data using CSV files, like not using, which were in CSV files. And then once we did that, we did some plotting with Matplotlib, charts with Plotly as well. Uh, we learned about OHLC. We learned about candlesticks, plotted those things. Then in the last session, we actually plotted a bunch of things like Bollinger Bands. We plotted like momentum indicators like RSI, volatility indicators like Bollinger Bands, MACD calculation. Then we did some calculation on return analysis and volatility, which we did not really use yet. Plotted the technical analysis. We spent some time understanding what the gap between the Bollinger Band means, the actual stock price, the simple moving average, the exponential moving average, uh, MACD moving averages, convergence and divergence, which we actually saw right here. Okay, so we understood what is signal line, we understood what is MACD line, uh, plotted those things, this histogram of distributed daily returns, if it's in a bell curve format, suggests that it was a random walk. We learned a lot about random walk in session 2, I think. One of those things. Not one, definitely 2 or 3. Okay, and yeah, that's where we ended. And before we went on a break in the previous one, there was a very nice question asked by someone which I had not answered because it's just less slow on time. uh, so let me answer that one very quickly, which is like, let me paste the question first in the chat. So the question was from users with username Zelkova Tree, and this was the question which I am sending in the chat right now. So there was a question that would it be possible to overlay a symbol representing major market affecting events related to, let's say, one of these Amazon, Google, or Tesla, like one of the stocks that we were analyzing, and onto the bars on the extremes in the histogram. Example, like let's say merger happened or something. So yes, it is definitely possible to add that, but ideally you would want to add that on a analysis one. Okay, so something like this, where you're doing the technical analysis, where you have the stock price, that is where you would ideally want to put this these kind of events. So I actually went around and I remembered that there is a company that offers this thing. I'll show you two things actually. uh, okay, so these are the two charts that would give you a better idea of uh, things like, let's say, plotting mergers, events on this. So overlay these things. So there is your chart. Then you can choose what to like display, and on a normal chart or on the technical analysis chart is where you would display these things. There's another company called Netdania, Netdania, Netdania. Very costly, but they also give you these charts where, let's say, events are happening here, something related to US, something related to Europe. uh, so on hover of that, you can see the events, but the important part is getting the data. If you can find the data of uh, these events happening, then you can definitely plot them on the chart. So this one is a FX currency, it's a euro dollar uh, currency, FX trading, and it shows on a candlestick chart about what the prices is, and when something is going down and there was an event happening, based on the event you could make an analysis of, yeah, this is why probably it's going up or going down. Okay, so that's the answer to the question. Hopefully that helps. Now let's move on to the last and the final bit, which I actually did right. Okay. Uh, so the last bit that I want to do in session 4 is plotting the exact same things that I did before, but the only difference is that I want to do it in Plotly. Okay. So I will make that addition here in Plotly, and then we will end the session 4 part and start with session 5. So this chart, okay, specifically, let's say the plot technical analysis, the plot MACD line, this is what I want to show in Plotly so that you know how to make an interactive one. Okay, that's a very simple way of telling it. So let's create a function, create interactive plot or technical analysis. This one taken a data frame and a ticker. And now after this, let's do a df clean, and that would be df dot reset index drop equals to true. Not really actually required, but for, let's say, for the sake of it, we are doing a reset index to ensure that the date column is the index column. Okay. Oh, hey, hi. Hello. Lol. uh cool. Moving on. Focus on the screen. So the next steps to plot this one, and this is like when I was trying this out, I found an issue. So we have to flatten the columns. Okay, otherwise it becomes a problem with Plotly. It does not recognize it. So yesterday we used this is instance thing from Python. So in our case, we will say that df clean dot columns. Okay, if any of them is an instance of PD, that is pandas dot multi index. Okay, so this was, we used this is instance yesterday or day before, when we were checked, or I think on the first day probably, when we were sorry, first session, not first day, first session probably, where we were checking if a value is an instance of a string. If it's instance of a string, do something else, do something else. So that's what we are doing again. So we are checking for each columns in the df clean. If any of them is instance of this pandas multi-index, then in that case, df underscore clean dot columns, and we will say that call of 0 if is instance call comma tuple, else call for call in df underscore clean dot columns. Okay. uh Platin. And to help make more sense, I will print the df before and the print the df after. Mm, okay. So let's use one of the things that we have. So I am going to invalid syntax, but it would be call of 0 if instance of column and tuple. Okay, perfect. So now we had Amazon df, right? So let me call this function with, it needs a data frame. So in our case, I will, let's say, give it a Tesla df. No, TSLA. That was my data frame. Yeah, TSLA df. And the ticker would be TSLA. And if I run this, okay, what's the problem? Df clean, df clean, df clean, df clean. Ah, this is a problem. Df clean. Okay, perfect. Okay, so before, this is what it looks like, and after, this is what it looks like. So before, I think unless we actually plot it, then you won't see the exact error that I was seeing, because of which I had to do this. Okay, we'll do that. We'll plot it with and without, and then we'll see this. Okay, I'm going to leave the print statements for now here. This here, and let me just go ahead and build the next bits. So the next bits, I will define a figure which is going to be px. What is px? That was the plotly express that we had downloaded, or like added as a library. Sorry, px. Px dot align chart, and what we want is give it provided dot line, and inside this we'll give it first the df clean, that is our data frame. On the x-axis we'll plot the date, on the y-axis we will plot the close, and the title would actually be a ticker, okay, which we'll receive from here. So ticker, and then space interactive price chart. Okay, then next thing is, if you remember in our technical analysis, we actually plotted a bunch of things. Sorry, we plotted the actual price, then we plotted the 20-day SMA, 20-day EMA, upper Bollinger Band, lower Bollinger Band. So let's plot all of those as well. So to do that, I will do fig dot add underscore scatter, and inside here we will say on the x-axis we will use the df clean and plot the date column. On the y-axis we will use the df clean, yep, this one, and plot the SMA 20, simple moving average 20. Okay, the mode would be lines, so plot lines, and we'll give it a name equals to 20-day SMA. 20-day SMA. And I'm going to copy this and paste it a bunch of times. Okay, so 20-day SMA is done. The next one would be 20-day EMA. The column name was called EMA 20 and 20-day EMA. The next one would be the upper Bollinger Band. So that would, the column name was called upper underscore BB. This one would be lower one. So lower, and this would be called upper Bollinger Band, and lower Bollinger Band. Okay, so yep, these are all the things that we want to plot. Then let's update the layout with fig.update underscore layout. On the x-axis, underscore title, we want to show that, like, we'll write a date. On y-axis, underscore title, it is always price, right, in dollars. Then what else? We can change the template actually. Yes, you can use plotly underscore dark template for a dark mode. Don't forget the comma there. And that's it. And finally, we'll return the figure. Return figure. Okay, so I think this is everything. So if I run this, okay, fine. And next is, let's assign it to a variable. So fig equals to this one, this function, and it takes in the tsla underscore df, comma, the ticker name, so tsla, and then we will do fig dot show. Okay, now if I run this, there we go. So this is the output, and if I hover over it, okay, now it shows you the actual price. You can also zoom in a bit. Okay, so there is your 20-day SMA, your 20-day EMA, there is your actual price, there is your upper Bollinger Band, there's your lower Bollinger Band. You can pan around and see all the data. Okay, and if you want to add, if you only want to plot, let's say, if you only want to plot the MACD line and the signal line, okay, so in that case, let's say I comment, oh, also I wanted to show you the error. So if I remove this part and run this, there's the problem. Value of x is not the name, of a column in data frame. Expected one of these things, but received date. Okay, so seems like there is a tuple here, okay, for everything, but it only gets this date. So it's basically was cleaning that, and that's why I added that. Okay, next, as I was saying, yeah, if you only want to plot, if you only want MACD and MACD underscore signal, what you could do is, let's say I'm going to comment all of this thing, technical analysis plotting. If you only want this part, then in that case you could do like fig equals to px dot line Uh, what would be my x-axis? Would be df underscore clean. Actually, let me copy this. Nope, not this one. Okay, x-axis would be this one. Y-axis would be actually MACD. Uh, and I can just go for this title. Okay, and then we can copy these two scatters right here. And on the x-axis, this is fine. This would be MACD, mode lines, and this would be MACD. And on the second one, date is fine, and this would be MACD underscore signal. Mode is lines, and this would be MACD signal. And everything else is fine actually. So if I run this, there we go, the MACD signal line. Okay, so if I come back on screen, so sorry, this is what we can see here. What's the MACD line showing us along with the values on it. Okay, I think much better representation. Similarly, you could do for Amazon and Google. Okay, so that is the end of kind of session 4. uh, comment the okay. Also, why am I commenting it? You could technically plot both of them together. Okay, the only problem is that it would look very small and squished. It's not working. Wait, sometimes it feels like it gets cached, because of which it doesn't work. So if I rerun everything, then it should technically. Oh, sorry. Also, this needs to be gone. It wasn't caching, my bad. Okay, when you plot everything, MACD would be between this and this. Okay, 0 to like -1 to 1, kind of. No, actually, -10 to 10. Uh, but yeah, the range of that would be very different than the range of actual stock. If you plot both of them, then your graph definitely is unreadable, I feel. Okay. Also, you can pan around by clicking on that pan option, moving around. So, yeah. Okay. So that is the range -25, -32 plus 30, probably. 40. Okay, you'll have to check. Whatever is the range, basically, depending on something or the other. Uh, okay, so let me push this. Let me save this first, and let me push all of this to GitHub, and then we'll move to the next bits. I'll amend to the previous commit. Okay, so now if you go to the GitHub, session 4, the IPy notebook. I did not create a Python one this time. We'll do that after the end of sessions. Uh, you should have kind of everything. Okay, everything that we did, along with the latest Plotly one. I will share the link in the chat. Okay, so now that session 4 is finally complete, I've answered all the questions and there are no further questions. Let's move on to the last bit of this session, which is going to be machine learning. Okay, so now before we move ahead, let me come back on screen. Okay, yes, so machine learning session. And what we are going to do is we are going to predict what will be the price of certain stocks on Monday, like tomorrow. Okay. We will use the data of like last 5 years. I'm not saying that this would happen, happen, but this would be the price. But let's use some very initial, like base, not exactly basic, uh, the initial bits of machine learning. Let's slowly get into machine learning. We will predict the prices of Netflix. Okay. Mastercard, Visa. What else? What else do I want to predict? Netflix, Mastercard, Visa, Meta, Tesla. Okay, so five companies. Actually, we can add Amazon and Google to it as well. So seven companies. I want to predict what will be the stock price of all these seven companies on Monday. Okay, what would be the excuse me? What would be the opening price, closing price, like one of those things on Monday, and we will use linear regression model to actually calculate it. Okay, so I hope you're excited. Can I get some excitement in the chat if possible? If not, that's fine. Okay, I'll still go ahead and teach this, but I would love if people are actually excited about this, because it is going to be I think a very fitting end where we'll check the price of the stock over the last 5 years, use machine learning to actually learn those prices, plot what were the actual prices versus what our machine learning predicts the price to be, and finally, towards the end, we will have that on Monday, the chance, like there is a possibility that the price of this stock, this stock, this stock, this stock, and this stock would be this many dollars. And then tomorrow I'll take a look at the opening and the closing prices of the stocks and see if the linear regression model that we use actually works. Okay. Or actually worked, or how badly it failed. Now, note that these price predictions are definitely not accurate. The machine learning model that I'm going to build will definitely not be exactly accurate, because price is a factor driven by markets. Okay, so markets and market sentiments. So what if something happens by end of today, which might change the price of everything tomorrow? Okay. So what we will do, we will create a session 5, but before that, uh, let me give you a bit of an overview. So we'll get the historical data of 3 years, 5 years. We'll try both of them. Okay, and then we will create features or measurements. Okay, which would be daily returns, moving averages, volatility, lag features, all those things. Then we'll train our model. Okay, a machine learning model, uh, and we'll predict the price. Okay. Okay. And along with linear regression, depending on the time that I have left, I'll also try random forest. Okay. So what, like, before we move to the coding part, a bit of a theory. So what is linear regression? So linear regression is like drawing a line which best fits the overall structure. So example, if let's say, uh, imagine this black line, which is the actual, not imagine, you can see this black line, which is the actual stock price. So a linear regression would be like drawing a straight line at points which best fits all the data points. Okay. So which line here, which line here, so like kind of a straight line which covers nearly every dot here in this case. Okay, then kind of a flat line or a angle line which covers most of the points, then a angle line like downwards line which covers most of the data points. So it's like a drawing a line through everything which best fits the whole thing. You won't actually draw it one above the other. You try to draw a straight line as much for as much time as possible, as long as it covers all the prices, okay, of that has happened. uh, the other one that I want to uh, like try out is random forest. So okay, so random forest, you can think of it as uh, asking too many people, okay, asking people uh, to best guess the price, okay, and they'll make a guess. They'll be like, oh yeah, it is going to be this, it is going to be that, it is going to be this, it is going to be that, and then take a average of what they are saying, okay. So that is random forest, and as the name suggests, it is random. And most often in stock pricing, I don't think that would work out well. uh, but we'll give it a try depending on the time that we have left. Then there was this other term that I used, which was feature engineering, okay. So uh, features are like things that we create to help our model understand the pattern. So example, in we will create a feature where we'll say how much did the price change yesterday, or what was the average of the price in the last 5 days, and use these features. So like, we created this Bollinger Band. How much did the Bollinger Band change? How much was the change in the standard deviation? How much was the MACD? Okay, like how far or how near, or is it up, is it down? So these are all features that we are creating. What was this simple moving average? What was the exponential moving average? So these features, excuse me, yeah, these features help a model, a machine learning model, understand patterns. And once they understand patterns, it makes it easy for a model to predict the output of the like the next day, okay, or predict the price next day. Then we will do model training and evaluation, where training is like teaching, of course, and then the evaluation part, or there will be a testing part where we'll check if the model has learned everything well. And then we will test how good has it learned, or is it accurate enough, by using things like MSC, okay, and R square. And finally, we'll do the prediction and the visualization, where we will, based on what it has learned, we'll ask it to predict what will be the price of certain stocks on Monday, tomorrow, and also draw a line showing what was the actual price versus what did our model predict. Okay, so yeah, that's it. MSE is a mean squared error. It is a number that tells off how far off the guesses are. So it needs to be as small as possible. Okay, the error needs to be as small as possible. That's how you remember it. And R square is basically how much of the price changes the model can explain. So it needs to be closer to 1. So 1 is like 100%. So if the model can explain 100% of the changes, then it is a very good model. If the model can explain 0% of the changes, it's the very bad model. Now if it explains 100%, there is a term called as overfitting. It feels like, nah, this model cannot be that good that it knows everything that's going to happen. So it needs to be closer to 1. So it needs to be closer to 100%, but exactly 100 is always bad. Okay. Uh, yeah, I think that explains everything. Okay. Okay, let's start building this. I have pushed everything. So I am going to close this one. Uh, reload. Everything is fine. Actually, let me shut this properly. Close and shut down notebook. Go back one step and let's create a new folder, session underscore 5. And inside this folder, I'm going to create a new kernel. We'll call it session dash 5 notebook. Okay. We were opening everything in Jupyter Lab, so I'm going to click that one. And I'm going to come here and close this. Yes, leave this site. Yes, reload. Everything is fine. This one should be up and running. As I can see here, 4 is still running. Can shut down 4. So I only have 5 running right now. Perfect. Okay. So, okay, before we begin, any questions, anyone? I'll explain the theory once again once we start writing the code. But I gave you, I think, a good overview from my perspective. Also, the R square, I think it's called the coefficient of determination. Okay. And we don't have to know the mathematical formula of it. We don't have to calculate it because thanks to the library that we are going to use, which is scikit-learn, it will help us calculate all those things. Okay. So that should not be a problem. Okay. Let's start. Perfect. Nice. Always love this. That we are ready to go. Okay. A bit of a markdown first. What are we going to do? We are going to do a stock prediction using machine learning. Stock price prediction using machine learning. And we will use scikit-learn. Okay. Scikit-learn or scikit-learn library for machine learning or ML. Okay. Perfect. Let's get started. Now, before we start, we actually have to install the library because I'm pretty sure we don't have it installed. So I'm going to clear this and you have to do pip install scikit-learn. So let me also share this command in the chat. Sorry about that. Okay. So pip install scikit-learn, the command is in the chat. So please do run it to install scikit-learn library. Once installed, we'll start importing everything from there. Okay. So what all will we need? We will need a bunch of things. Import numpy as np. We will import Yahoo Finance again because, well, we need the stock data, right? Then we'll import matplotlib.pyplot for plotting, imported as plt. Then from scikit-learn, and it is the library is sklearn dot linear underscore model import linear regression. Okay. And from sklearn dot metrics import mean squared error MSE and R2 or like R square score. Okay, so these are the things that we will import. At least these are the things that we require. This might be a new pattern, so like the from pattern. So this is one way of saying that in from inside, like sklearn is the outer folder. Go one level deep and search for this linear model folder, and from that import this particular file, class, file, method, whatever you call it. So yeah, that's one pattern of importing things. Okay, now what else? What else? We'll write functions. Okay, functions, and this time we'll make it. We'll write everything and then try out stuff. Historical data or get historical data. What is historical data? Get historical data. So we will define a function get underscore stock underscore data, and we will say that this is a ticker that would be of type string. Let's also do some types so I can show you how to do that. Uh, so from typing, which should be built in, import dictionary tuple anything. Okay, so we are using typings in Python because that is a possibility that you can define the types of data. Okay, so ticker will be of type string. The start date would be of, what am I writing? Start underscore date, and this is going to be of type string again. The end date would be of type string again, and this will return, uh, what will it return? We'll only do a download. I'm going to say that it will return anything. Okay. Yeah, because I don't know what exactly would it would be. What uh should be a data frame, I feel. Data equals to yf dot download, and we will pass it the ticker. We will pass the start equals to start underscore date. The end would be end underscore date, and we don't want to show the, actually let's say we want to show it, the progress line. Okay, and we'll just return this data. So this is our first function. Any is, oh yeah, this one and this one, perfect. So we have also started using typings in Python. Okay, which means that we can define the data type. uh, if you know, Python is not a typed language. Example, JavaScript is also not a typed language. But by using TypeScript, you can add types telling that, oh, this data is of type this data is of type this. So we're using that as well, so that I can introduce you to typings in Python. Okay, the next one would be some feature engineering that we will do. So feature engineering. So function definition, engineer features, and this will take in data, which should be of type pandas dot data frame. Okay, and it will return. Okay, so this arrow, one like minus and then greater than, so that is an arrow. So returns pd dot data frame. Okay, so step one. So what are these features? Example, the return. Okay, we'll calculate how much did the price change compared to yesterday. We will calculate the simple moving average SMA of 5 and 10. So average price over 5 days and average price over 10 days. We'll use volatility. We'll also calculate volatility 5, which is the 5-day standard deviation of the closing prices. Then we'll create a lag feature, okay, a close lag feature, which would be like what was the price 1 day ago, what was the price 2 days ago, what was the price 3 days ago, and then the target, which is the price for the next day, which is what we want to predict. Okay, so let's start by first creating a copy of the data. So df equals to data dot copy. Okay, so why we making a copy? Because we don't want to modify the original data. Next one, let's say calculate daily return. So df of return column, this is a column that we are creating, and that is nothing but the closing price of uh, the original data, and then pct underscore change, we are calculating the percentage change. Okay, then calculate moving averages. So we'll create two more columns, sma underscore 5 equals to df of close dot rolling, and window equals to 5 dot mean. Okay, so average of 5-day period. Similarly, let's create a df of, I'll copy this one because I'm lazy, sma 10, where it would be df of close price dot rolling window of 10 days dot mean, which is the average. Then next is to calculate volatility. Calculate volatility. So this would be 5-day standard deviation from the closing prices. Okay, so here we will say volatility underscore 5. So df of close dot rolling and window equals to 5 dot std for standard deviation. Okay, oh, there's a question and there's an answer. Perfect, thank you so much. I definitely like the username. Crackers and cheese, quackers and cheese. uh, Good one there. Okay, sorry, that was my deviation from our model. Let's create the lag features. Okay, and this would be closing price from 1 to 3 days ago. So we are creating 3 new columns called as close lag 1, close lag 2, close lag 3. And what we are doing is we are going to we are going to okay, let's actually, when we start doing it, that time you can see the data. But what we are doing is, if let's say there is a column, okay, there are rows, 1 row, 2 row, and 3 rows. So this is first row, second row, third row. The price of this first row in the column close lag 1, the closing price of first row here will be visible here, and this would be na. This one would be visible, like closing price of first one, and yeah, and here we would have close lag 2, close lag 3. So close lag 1, close lag 2, close lag 3. Close lag 1, second row will have closing price of first. Close lag 2 will have na, but close lag 2 here will have the price of the first row. Close lag 3, okay, close lag 3 would have na, and this one would be the price of this, like close price of first row. Why are we doing this? So that our model can remember that, oh, the price here is this, and the close price 1 day ago was this, close price 2 days ago was this, close price 3 days ago was this. So that helps our model learn from the past data. It's like remembering what happened yesterday. Okay. And it basically gives the model more context about what happened uh, a day before, 2 days before, 3 days before. And you can increase it. Okay, you can capture like up to 5 days, 10 days, 15 days ago, all those things. Too much is also a problem, too less is also a problem. So you need to test around to find the optimal one. So let's create this function. So I'm going to say for I in range 1 to 4. So this is like 1 to, so this will go from 1, 2, and 3. Okay, it will not go to 4th. The last one is excluded. And we will say df of, I'm going to use f strings, and because I'm going to say close underscore lag I. So I will be replaced with 1, 2, and 3. And that is nothing but we will take the close column and then do a dot shift by those many days. Okay, so we'll shift the prices up and down, from up to down. Okay, that ways. And then the target. So this is what we want to predict, which is tomorrow's closing price. So df of target excuse me, sorry about that, df of close dot shift of -1. Okay, so we are shifting it by -1 to predict the next day's price. Then I'm going to print the processed data, \n processed data, colon \n \n. No, one is good enough. And let's print the df dot head and like top 15 rows. Okay, then we will remove rows with missing values. So you know what we do here, we do a drop na. So df dot drop na and in place equals to true to modify the data frame, but not the original data frame. Why? Because we have the original data frame is called data, but our copy is called df, and our copy will have these new things, and our copy will be updated by removing all the nan values. Okay, and now we return df. So this is what the in feature engineering one will do. PD is not defined. What do you mean? Oh, did I not import pandas? Nice, so smart. Import pandas as PD. Okay. So now 1, 2, 3. Okay, everything should be fine. Perfect. So we have done some feature engineering. Now let's do data preparation. Okay. Prepare data for modeling. Data modeling, not modeling. Def prepare underscore data. This will take in the data frame which would be of type, of course, pd dot data frame, and it will return a tuple of two things. One would be pd dot data frame, and the other would be pd dot series. Okay, now okay, so what we want to do inside here, so we want to define a list of columns. Okay, that's the simplest way to understand. We will define a list of columns that are going to be forwarded to the training and testing, like to the machine learning model that use these columns to learn and then do training and then do the prediction. So I'll create a features equals to, this would be a list, and it would have like close underscore lag 1. If you add more here, okay, let me add a comment saying, if actually let me add a comment here, if you increase the lag features here, also update prepare data. Okay, so close lag 1, close underscore lag 2, close underscore lag 3, then focus on the SMA underscore 5 column, SMA underscore 10 column, uh, volatility underscore 5 column, and the return column. So these are the columns that we want it to use. So this is like selecting the features or the measurements and our target variable, which would be the target column. Actually, the one thing that we want to predict is the target column. Okay, so our X is going to be df of features, okay, data frame of all these features, and our Y is going to be df of target column, okay, the prediction, and we will return X comma Y. Okay, so if you, I hope this makes sense about uh, this is basically selecting which columns to focus on, and this is basically selecting this is what you want to predict. Okay, this is the column that you want to predict. Okay, so the next bit is the splitting of training and testing data. So let me run this. Okay, done. Train, test, split. Okay, so now we have like limited amount of data. We have like, let's say 3 years or 5 years of data. We can't give the model all 5 years of data to train. Why? Because how do we test our model then? If it has learned, if it knows what happened in the last 5 years, and if I tell it to predict the price of last 1 year, it will predict it accurately because it has seen that data. If it has seen that data, then it knows the outcome of that. But we don't want that to happen. So we will split the data. And the default normally is that 80% of your total data, let's say if you have 10 data, then 8 of that will be used for training, 2 of them will be used for testing the output of the model. Okay, testing how does the model has learned well or not. So in our case, we would split again between like what, 80%, 20%. Okay. Okay, so let's create a function. So def train underscore test underscore split underscore this is good enough, train test split. And then it would take in X, which would be type pd dot data frame. And also, actually, this would be a time series. So I think telling that it's a time series is a good thing. YD is PD dot series. Uh, and the split would actually be of type uh, float. Okay. And by default, I will say that this is zero point 0.8, which is 80%. And this will return a tuple. Okay. Tuple is basically returning two things. That's as simple as it gets. Or two things, four things, whatever. Like you return multiple things. Okay. So now we will create a split underscore index idx, and that is going to be integer of the length of x multiplied by split. Okay. So if there are 10 things in the data, so length, or like 10 things in the data means that the length of x is 10. 10 multiplied by zero point 0.8 would give us what? 8. So this should return a integer 8. Okay. So split index is 8. And then what we will do is from 0 to that index. Okay. So 0 to 8 would be the training data, and everything after 8 would be the testing data. So ninth and 10th would be the testing data. That's what we are doing here. So here we will return x dot I log. Okay. I log, I think I did not exactly teach you that in uh, when I was talking about lists, but ilog is basically for selecting rows by index. Okay. So here we will say from the beginning, like this is, if we don't use anything, that it means 0. Okay. So from the beginning, go up to split underscore index. Okay. And we'll also return dot ilog everything after split index. Hopefully all these spellings are correct. From split index to till the end. So this is what that represents. Okay. So colon and then empty means till the end. Similarly, we will do for y. Okay. So colon and split index. And y dot I log from split index till the end. Okay. We want everything. Okay. So that is the training test split time series. Perfect. So that is done about the training and testing data split. Next is the model training. Okay. So we need to write a function for training the model. Okay. So, well, this one should be named simple enough, train model. And this will take in x underscore train. Okay. So the variable I'm calling is x train. That is the training data features, training data features, which would be actually of type pd dot data frame. Then it would take in the y train, which is the target, and that would be pd dot series. Okay. The model type. Okay. uh, I am going to create a model type string, and by default it is lr, which is linear regression, uh, and this returns any. Okay. I'm not sure what it will return, so I'm going to use any. uh, Using any is same as saying that actually we are not using any type. Okay. Just return whatever it does. So what are we doing in this function? We are going to train a machine learning model to predict the next day's price. We will have more choices in the future. Right now, I am going to say that the default is linear regression model. But if we have time, which let me see, uh, hopefully we do, we will actually try random forest as well. So we'll, like when we use this function, we will say that if the model type is RF, which is random forest, then do this. If the model type is LR, then do this. If you want to add more models, you can do that. uh, okay. uh, okay, let's add this. So we'll first check if model underscore type double equals to LR. Okay, if it is LR, then in that case we will create a variable model, and model is equal to, we imported linear regression on the top, we'll call the linear regression model. So everything, like for now we'll go with every default. Okay, the default that is coming from scikit-learn, and then we'll look at the documentation to see what extra could be added. Else we'll just print model type not available, and then the model, okay, this variable model dot fit x underscore train comma y underscore train, and we will return model. Okay, so what does this fit do? The fit is for training the model. It's a method available for training the model, where we pass it the training data and the target. Okay, and that's it. That is our training stuff done. Next is the evaluation of the model. Okay, so model evaluation. Now in this case, again, evaluate underscore model. So well, this will take in a model. Okay, and we don't know what is the type of that, because our training model returns a model which is of type any. So then the same type will come here, that the model is of type any. The x underscore test would be of type pd dot data frame, and the y underscore test, so this is for testing, and this would be pd dot series. Okay, and what we will make it return is a dictionary of string and float. Okay, that's what we will make it return. Why a dictionary? Because inside the so inside this we will do a model prediction thing, and then we'll return the mean squared error. So we'll create a key called as MSE, and the value would be what is the mean square error. We will create a key called as R2, which is R square, which is R2 score, and we'll also create a key called as predictions, which should return us the predictions. Okay. Okay. So now y underscore pred, that is the prediction, and we will use the model dot predict x underscore test. And then we will return, as I said, a dictionary. So MSE is what we will return, and that would be the mean squared error. Okay, this one. So mean squared error, it needs two parameters, the y test data and the y prediction. Okay, so what is the actual value and what is the predicted value, and based on that it will calculate this mean squared error. Create another R2, because you can't create R square as a key. and that would be R2 underscore score. Okay, so this thing that we have imported. So R2 score, and that would take in again two things. It would take in the test data and it would take in the prediction. Okay, and if you remember, uh, MSE is how far off the guesses are. So the lower the better, and R2 is how good is the model, how accurately can it predict or explain the changes. So the closer to one it is, the better. Okay, but if it is exactly one, then there is a problem, and you definitely need to tweak some parameters. And our predictions will also return that. What was the predictions that was returned? Okay, so there is that. What next? Let's plot the predictions. Okay, that ways we will actually see what happened uh, with the actual data versus what happened with the predictions. So plot predictions, def plot underscore predictions. This will take in the y test, okay, which is going to be pd dot, not pdf, pd dot series, and y underscore pred, that is a prediction. It would actually be a numpy array, nd array, array. Yes, then it will take in the ticker, that should be of type string, and it will take in the model underscore type. Okay, that would be again of type string. The model type is this one. Okay, so lr or something else. Like for random forest we'll have rf, uh, whatever other models that we use. uh, what does this return? This actually does not return anything, because it will do the plotting inside here. Okay, it will not have a return. It will just do plot.plt.show. So nothing is going to be returned from here. So plt.figure, and inside this we'll define the fig size equals to, let's say, 12,6, which is the default normally. Plt.plot, and inside this we will have uh, what should we, okay, we can have the y underscore test dot index, uh, y underscore test data. Label could be the actual price for this, and we can color it blue. And now we can copy this line and paste it right below. So now this one would be, we are going to plot the y test index, but instead of y test data, we'll plot the y prediction data. The label would be predicted price, and the color we will go for orange. Okay, cool. Then we can actually do the title, plt.title, and we will do f strings here, and I will say that since we'll have multiple, so ticker actual versus predicted prices, and then we'll also write the name of the model. Okay, so model underscore type, plt dot x label would be date. So on the x-axis, yes, this was the term that I forgot in the last session, axis. Wow. Plt dot y label would be the price. Wow, I feel so stupid right now that I forgot the word axis. Then we'll show the legend. Of course, we'll use the grid. What else? Plt.x ticks ticks x ticks. So on the x axis, will rotate what the dates by 45 degrees, okay, so that they are better visible. We'll do plt dot tight underscore layout and plt dot show. Okay, this should be good enough. uh, okay, so that is the plotting predictions. And finally, the last thing that we want to do is predict the next day prices, right? So def predict next day. Okay. uh, uh, I had such a good numbering going on. Now that's spoiled. But if I delete this, predict next day price. So def predict next day, it will take in model, which is of type any, because we have not defined the type of model on the top. The latest underscore data. Okay. The latest data would be the most recent row of the data with the features. So pd dot series, that is what it would be. And this should return a floating point number. Okay. So step one, we'll define the features here. So actually this array would be the same as this one. Okay. So it will have the list of features: close lag 1, 2, 3, SMA 5, SMA 10, volatility 5, and return. So actually, let me make one more change here. Also update prepare data, comma, predict next day. Okay. Of course, you can improve the code, take the features outside, and put it at the top as a array. Should have done that. I realize that right now, but that's fine. Then we'll do a prediction underscore features, and we will do a np numpy array, where we will do a latest underscore data, excuse me, f for f in features. Okay, so for every feature, latest data of that, like for every item in this array, in this list, whatever, uh, we are going through the latest data of that. And dot reshape 1 comma minus 1. Okay, so what is this doing? So it is reshaping to 2D array. 1 comma minus 1 means that uh, one row and unknown number of columns. Okay, so reshaping it into a 2D array, and then we will return model dot predict prediction features of 0. Okay, so getting the value of the 0th index, and this is basically predicting the next day's price. So I think that should be good enough. Okay, let me run this. Then let's write our main function. Okay, main function, and this would be called main, def main. And what will this have? We'll provide it a start date, which would be, let's go for 5 year, so 2020 dash 02 dash uh can I have a calendar? Okay, Feb 2020, the Monday was on, we can actually go for 7th of Feb, which was a Friday. Market should have been open. Uh, so 7th of Feb, okay, 2020 uh, is our start date. End date, that would be up to this Friday, which was 2025 Feb 7th. So 7th Feb 2025. Okay. The stocks that we want, and I am going to go over a lot of them. So Tesla, Meta, Mastercard, Visa, uh, Netflix, Amazon, Google, JP Morgan, Microsoft. Okay. So every so all the stocks that we have used till now, plus some extra. Okay. So these are the stocks that we will go through. And what we need to do is make the prediction date, which will be this Monday, which is going to be 2025 dash Feb dash 10th. Okay, that should be tomorrow. For me, it's tomorrow, but let's say this Monday. Then the results. Result. It's going to be a dictionary, empty dictionary for now. And for ticker in stocks, okay, so for ticker in stocks, okay, for each ticker in the stocks, let's do some printing first. F string backslash n, processing whatever ticker, dot dot dot. Okay, so this one will be a good one. So step one would be to get the data. Okay, so get the stock data. So to do that, we will create a data variable and call the get stock data function. And we will provide it with the ticker, the start date, and the end date. So start date and the end date. Okay. Once it has the ticker, the start date, and the end date, it should get the data of like between these for all of these one. Okay. The step two would be like this is our step one. This is our step two. Would be to create features from the data. Okay. So that would be, let's say, processed data is equal to the engineer features that we created. This one, that's what we will call, and that takes in the parameter of just the data, I think. Yes. Okay, so this data goes here. So that is our data. Then the third part is prepare the data for our model. So in this case, it returns a tuple, right? The prepare data. Okay, it returns two things. So that's what I'm going to use, equals to prepare data processed underscore data. So whatever is returned from here goes back here. Then step 4, okay, split the data into training and testing. Note, we are not shuffling data because order matters. Okay, so order matters to us. Why? Because it's a stock price data. If we shuffle the data, what are we basically saying? There is no way to know then what was yesterday's data, because we are using these feature lag, right? That checks what was yesterday's data, creates a new column, provides that data into that column. And if you shuffle the order, then there's just no way. Because remember, stock prices, they depend on previous day's data, random walks, cumulative sum. Remember all of those things. Okay. So whatever I have taught you till like session 4 was a building block for this session 5. Cool. Oh, sorry, there are two questions. Uh, Notice that it has this own. So one of the reason is so that I can actually show what we do, and secondly, I'll have to check hopefully that they don't do shuffling of data. I can take a quick look again. I had done it, but I forgot about it. So thanks for pointing. But for now, my idea was that I'll show you what we do in actually training and testing. Okay, and yeah, thanks about this. Yes, yeah. Sometimes I just forget words. Okay, so X and Y process data that is done, and then plot. No, not plot. It is split the data into training and testing. Note, we are not shuffling data because order matters. Okay, order of the data matters to us a lot, and this will return us a tuple of four things actually. So X train, X test, Y train, and Y test. Okay, it returns us four things. What was the name of a function? I forgot. Uh, Train test split TS. And X comma Y. These two things are now passed here. Okay. Once this is done, our fifth one is the training our models. Okay. So for this one, we will call the train model function, and that returns anything. So what I am going to do is, for the sake of the future, I will create models equals to, and I will have a linear regression as a key here, and the value would be train model, and it will take the input as x underscore train comma y underscore train, and the model underscore type equals to LR. Okay, linear regression. Okay, so train models. So later on, if we add more models, okay, when we add, like, let's say another model that comes to mind is random forest, right? So when I add random forest, I can add it right below here, so in this dictionary. Then next part would be actually uh, evaluating the models, right? We need to evaluate the models. So for that, I can do results of each ticker is a empty uh, dictionary, and now I can loop over it by saying that for model name comma model in models dot item. Okay, because models is a dictionary, so models dot items. Once you go over this, what we are doing is evaluation. Evaluate model on test data. Eval underscore results is a variable that I'm creating, and we will call the evaluate model, which is this one. Okay, so evaluate model function that takes in the model, it takes in the x test that we got here, and it also takes in the y test. Cool. Then we will do the plotting, plot the predictions, and also it plots the actual prices, right? Plot the predictions versus actual prices. So we'll call this function. We don't have to assign it to anything because there's no return value from it. It does the plotting internally. So we will pass it. What does it need? Y test, Y prediction, the ticker, and the model type. Okay. Excuse me. So Y test And from the evaluation results, this eval results, okay, we are going to pick out the predictions key. Okay, the pass it the ticker as well, and pass it the model name as well. These are the four things that we pass it. So that is our plotting done. And finally, the last bit would be uh, predict next day price. Predict next day price. Okay, so we will create a next day price variable, and we will give it to the predict next day. Okay, and that takes in a model and the latest data. So model comma uh, the processed data. Okay, that's what we will give it, processed data dot I lock of -1. Okay, so what is this one doing? So this one is the uh, location. -1 is the last row of the data. Okay, so that is the latest data that we want to give to it to predict the next day's price. uh, and then what else? Okay, we can store all this into results for a particular ticker, and in that, for a particular model name, so linear regression or whatever is the next one, and we can add the metrics, which is the evaluated results, and the prediction, which would be the next, what am I writing, next day price. Okay, so this should show that for, let's say, Amazon linear regression, the prediction, the what are the metrics, so what is the R square, what is the MSC, and what is the predicted next day price, what is the predicted price for 10th of Feb, let's say. Okay, so that's it for our for loop. We can come out of the for loop. uh, yeah, that was a very big for loop, I would say. So now I would, if I come out of the for loop, anything else? Uh, okay, we can print some more stuff. So print the prediction summary for whatever is the prediction date. Print, like, let's print some dashes. Okay, so if I do a dash multiplied by 50, it will print this dash 50 times. Okay, that's a neat trick for printing too many dashes. What else? For ticker comma models in results dot items, print uh, f string backslash n ticker. Okay, and for model underscore name comma result in models dot items, we can do a print for f string. Let me add a bit of a space so that everything is like nicely aligned. Model underscore name. I'm going to copy this, paste it a couple of more times. Okay, so f string, some space here, uh, right here. We can have MSE is going to be what? Result of metrics of MSE, and this would be up to 2 decimal places. Similarly, I want to do for the next one. I don't need a colon here. Okay, this one would be R square, result of metrics of R square. That would be 2 places as well. And the last one that we want is the predicted price. And that would actually be in dollars, result of, oh, I think this should be a single inverted, single inverted, single inverted, single inverted, single inverted, single inverted, single. Okay, perfect. So result of prediction, okay, and I want that to be dot 2f, and let's close this one. Okay, so dollar prediction dot 2f. I think this should be fine. That was a long main function. No errors, hopefully. Okay, perfect. Now let's just call the main function and hope for the best. Okay, there we go. Nice. So now let's look at the data, and let me come back on screen so that we can together look at the data. Okay, so looking at the data. Step 1, downloading the data. Okay, uh, processed date. Processed date? Did I write processed date? Data. Processed data. Come on. Wait. Kernel, restart, clear our output, and run all everything. Okay. So processed data for the first 5 days. Do you see this? So we got some data: close, high, low, open, volume, return is what we calculated. SMA 5 or over 5 days, the simple moving average. SMA 10 over 10 days, simple moving average. Volatility over 5. Close lag 1. Now this is what I wanted to show. So close lag 1 on 7th of Feb is NAN, but close lag 1 on 10th of Feb, which is the next possible date of available data, this value is same as the closing price of Tesla on the 7th. Close lag 2 is same as the on the second day, I would say, is same as the price on the first day. And close lag 3 has, like, that is on 12th, is the price on the 7th, and so on and so forth. So now if I go to close lag 2, like on 11th, it is actually the price on the 10th. Okay, so we are making the model remember the data so that by 4th day, okay, all of them will have like data of previous days. Okay, so we are trying to make the model remember what the previous data was. That helps it to train, okay, learn better. Then this is the plotting: Tesla actual versus predicted prices. Actual in blue, the predicted in orange. And if you look at it, I think this is a very good prediction, right? uh, Nearly got it right, okay, for most of the things. Sharp change here. The model did not predict. Sharp change here. Model did not predict. Okay. So this is what it got for actual versus predicted when we told it to remember prices of last 3 days. And prediction summary for 10th February 2025 Tesla linear regression model. Uh, Actually, let me remove one space from here. Yeah, this one would be better looking later. So MSE is 123.66. Okay. Mean squared error is 123.66. Okay. R square is 0.98 and predicted price is 382.63. Uh, for MSC, the idea was what was the idea? I forgot. Wait 1 second. Lower the better. Okay. And R square is closer to 1 the better. Yeah. MSE means squared error. The lower the better should be. And this is too high, I feel. Don't think this is 123.66 for everything. Is that? Let me check the last one. 128, 31, 11, 245, 12.55, 11.14. Okay, yes. MSC lower the better. There are chances of it being like this is lower as it gets. So MSC of first one is very high, which means that it might not be correct. Okay. But R square is 0.98, which suggests that it could be possibly correct. Okay. Because it's closer to 1. Okay. It is closer to 1. Yes. Then the predicted price of Tesla on Monday is 382.63. Now, let me see what is the current price of Tesla. What was the closing? So it was 361.62 on last day. On 7th February, it was 361.62. After hours, it actually dropped to 357. And our model is saying that on Monday, it is going to be 382.63. Take it with a pinch of salt. Okay. Definitely take it with a pinch of salt. Maybe a tumbler full of salt because our MSC is too high here. Okay. Meta. Let's look at that data. Meta actual versus predicted. Not too bad. Okay. Yes. Model prediction, not too bad, I would say. And MSC is, oh, this is Tesla and Meta. So MSC is still high. R square is this. Predicted price for Meta is 705. Okay. What is the current price of Meta? 714. So on Monday, it could drop, possibly. Sell it. The next one is MA, that is MasterCard. So for MasterCard, oof, don't think the graph looks very good. And let's see, for MasterCard, MSC is low. R square is very near to 1. Predicted price is 561.79. Let's see the MasterCard price currently. 562.75. Well, buying or selling would not make much more sense in this case because it's going to be moving like $1. Okay. So yeah, not very good for MasterCard. For Visa, okay, let's see Visa. Uh, okay, cool. Okay, so for Visa, the prediction. So MSC is very low, which means that the model has been very good with predicting Visa prices. It has learned quickly, learned good. R square is 0.97, closer to 1. It's not exactly 1, but closer to 1. Predicted price is 346.61. Let's see. 348.02. It could fall. Let's see Netflix. Uh, Netflix, not too good. Okay. Netflix is 999.08. MSC is too high. Okay. Uh, so definitely cannot believe this one. But let's see what's the current price. 1013. So saying it could fall by $15. That's a lot. Amazon. Amazon is fine in terms of charting. Uh, MSC is very low. R2 is 0.97, which is good. Predicted price is 238. Let's confirm. What not confirm? Let's check. Amazon 229.15 is where it closed, and 238. Okay, could make money there possibly. And Google, the last one in our this no second last one I think. Uh, MSC is very low. R2 is 0.96. Okay, cool. And 198.38. Let's see. 185, 198. Could make money there. Okay. JPM. Okay, JP Morgan Chase. The graph looks accurate, nearly accurate, which is nice. And let's see, JPM, what does that give us? MSC is low, R2 is near, and 269.09. Let's check JPM. 275, 260. Oh, going to fall down probably. At least our model says that. And finally, I think MSFT, which is MSC is slightly higher than others. 0.82, not really good prediction. Okay. And 412.06. Okay, let's see. MSFT 409, 412. Not much profit there, but even the output is actually bad. Okay, so this was our feature engineering and our machine learning model, the linear regression model, actually predicting out the prices. And very simply, as I told you, linear regression is like plotting the best fit line. And we saw how good it is in making those lines right now. Uh, One thing that I want to quickly try and show, okay, is adding a few more close lags. So I'm going to change this to 6, and 4 and 5 is what I want to add right here. And similarly, I am going to copy these and change it here as well. And let's see the amount of data. Okay, so I'm going to actually start from 2018. So that would be what, 7 years of data. Now kernel restart and run up to everything. Okay, over the last, I changed the date, right? Okay, these are our new predictions for Monday. The MSC has reduced a lot when we went for higher one. We need to check what happened with the charting. Why is it only showing from like 2023? Like I added two columns. What did I do wrong in the charts? Plot predictions, blah blah blah, date. So I added pros lag 1, 2, 3, 4, and 5. Okay. So these are new predictions when we went for more data. I'll have to check the charting, which I'll do after the session. But I'm nearing the end of session, last 9 minutes left. But okay, we have the MSE. Okay, the mean squared error has reduced here. So, and the R square has kind of improved, but it has gone to 0.99, which is very close to 1. I would take this with a pinch of salt. Might have to tweak the model a bit. So, what I would suggest is go to the scikit-learn linear regression, not neural network, linear regression, and see what other parameters can you change here. Okay. So I'm going to paste this in the chat, and there is a question, pretty nice one, which is how do we judge if the MSE is too high or too low? Okay, so there's this question: how do we judge MSE too high, too low? I don't know if there would be a rule of thumb. Let me think. Mm, but just say like currently looking at the data that we have. Okay, uh, it's not exactly something that we could say. Okay, unless we have more models, then MSE is much better. Okay, and in understanding, like right now we only have one model, so in that case it is not really beneficial in terms of MSE. That you know what's happening. So let's say when we have like three, four, five models, and in that case you compare MSE, then you can see that okay, the mean squared error of linear regression for Tesla stock is this, but if you use the uh, SVGR or random forest, the mean squared error either increases or decreases. So that gives you a better idea. Okay, that oh, is this like between models, which model is performing better. So MSA, you can think of it as between the models, which one is better suited. Okay. So one last thing is, let me take a screenshot, or actually let me copy all of this. Mm, and I'll paste it in the Discord chat. Okay. Like this is our predicted pricing of models. Actually, no, not Discord chat. Let it be here. I don't know. I'll probably get banned for promoting something. Uh, but okay, so this is where we end our sessions. Uh, thank you so much, everyone. Any questions before I end the stream? I know, right? Probably will get banned for this. uh, but take a look. I will look at the closing price of all these stocks on Monday. See if it actually is our linear regression model as good as it predicts. Uh, we have seen the data, and I will also push everything that we have done till now. This would be feet, and this would be added ML for predicting stock prices. Hit push. Okay, so everything that we have done till now should be available to you. Uh, yep, and all the code is in here. Okay, and yeah, I hope, like, okay, let's see on Monday. Okay, so what's going to happen? And another question, this would be available on Twitch, it would be available on YouTube, and thank you so much for this quackers and cheese. for the link to the YouTube channel of Major League Hacking. Okay, and yes, hopefully, if this is correct, I'm going to use this model to buy stocks. Just joking. Okay, please don't take it seriously. Uh, okay, thank you so much, everyone. And before I end this session, once again, a very humble request: please provide feedback. Would help me. Would help you. Uh, help me because then I'll know what exactly I can improve on. Uh, would help you because you get entered into a raffle, and also all these things that we do is for the community. So based on your feedback, we can improve whatever we can. Okay, whatever is humanly possible. Uh, if there's anything that you liked about the session, tell everyone. If there's something that you didn't like about the session, tell MLH. Okay, praise in public, criticize in private, and that will help me grow as a person and help you as well. Okay, cool. Thank you so much once again, everyone. Thank you so much for listening to me for 5 sessions. That is like 10 hours of listening to me. Uh, but I hope it was a good one and we learned a lot of things, right? I know, right? I don't know if it would be this, but if it is one, if the MSC comes down to one for everything that we do, yes, it will be legendary. Okay, so cool. Once again, thank you so much, everyone, and I will see you next time. There is one thing that I wanted to cover, which would be options and European options, American options. Let me go and find if I can get more sessions to cover FX. Okay, so foreign exchange and FX options specifically, because that is something that I'm currently working on. So I wanted to teach that. But before that, you had to know about stocks because you can't go into FX without actually knowing how market works. Okay. So yeah, cool. Thanks a lot and enjoy the next session after this. The next one is going to be a type racer mini event with Wei and Yashika. Okay, so definitely join them and have fun. Okay, cool. Cheers, everyone. See ya. Bye bye.